This is a true story. That's right, Einstein destroyed planet Vulcan. This is not a fictional account of some alternate reality of Star Trek. It really happened, and if you can keep your paws off your mouse for a few minutes, I'll tell you about it. It started with this guy, Urbain Le Verre. I think that's how you pronounce it. In 1846, he was checking observations of the planet Uranus against the calculated orbit. There was a small difference between the calculations and the observations. That would have been a great opportunity to tell his friends, I think there is something wrong with Uranus, or to tell his wife, I think Uranus is being perturbed by some unknown body. But sadly, Le Verre was French, and that joke doesn't work in French. I'm not sure if it works in English. What he was able to do was to calculate where the perturbing body was. He sent a letter to Johann Galle in Berlin and said, Point your telescope here. And when Galle looked, he saw Neptune, planet Neptune, as it would be called. At the time, Le Verre was only the second person in modern times to discover a new planet. By the way, since it was discovered, Neptune's been around the Sun once, and in 2010 was back to where it was when it was discovered. Now, when Le Verre realized that Mercury's orbit wasn't quite right, I'm sure he could practically smell an undiscovered planet. He was so confident, he went ahead and picked out a name. He picked the name Vulcan because the planet would be very close to the Sun and therefore very hot. Now, the Roman god Vulcan was hot, and by that I don't mean hot looking, quite the opposite. According to one version of the myth, he was so ugly when he was born, his mother Juno took one look at him and tossed him off the mountain into the ocean. He became the god of fire and set up a smithy shop under Mount Etna. Now, Vulcan is where we get the word volcano. Many of us probably think of Star Trek when we hear about the planet Vulcan. However, after exhaustive research, I couldn't find anything about how the creator of Star Trek chose that name. There were lots of people, mostly amateurs, that claimed to have seen Vulcan transit the Sun. Le Verre tried to predict where Vulcan could be seen, but no luck. It was hard to see it transit because Vulcan would be so close to the Sun. For this reason, some astronomers tried searching at night, but they had even less luck. Often, when a person would tell him they found it, he'd show up at their door. In 1877, Le Verre died, secure in the knowledge he'd found Vulcan, but he never predicted where it could be seen, so he didn't go with the epitaph, that's right bitches, 2 planets. A year and a half after Le Verre's death, Albert Einstein was born. This is where the story gets a little complicated. Don't worry though if you don't understand the science, and if you do understand the science, don't worry that my explanation may be completely wrong. That being said, this is my interpretation of what happened. Just as our observations about the movement of planets improved, our observations about the behavior of light improved. By the time Le Verre was chasing amateur astronomers around Europe, scientists were getting pretty close to accurately measuring the speed of light. As the accuracy of the methods improved, however, it appeared the speed of light was constant. For example, the Earth goes around the Sun at about 30 kilometers per second. Let's say the speed of light is about 300,000 kilometers per second, just to make the numbers easy. So if we measured the light from a star in spring, when we were heading toward the star, it would make sense that we would measure about 300,000 30 kilometers per second. But we measure 300,000 kilometers per second. In fall, when we're going away from the star, you'd think we'd measure 299,970 kilometers per second. But we still measure 300,000 kilometers per second. 30 kilometers per second is about 0.01% the speed of light, so the instruments had to be pretty accurate to notice that this was happening. Around 1856, James Clerk Maxwell recognized this as being close to what he was seeing in electromagnetic waves, and suspected that light might be a type of electromagnetic wave. The thinking at the time was that if light is a wave, it needs a medium to travel in. Like for waves in the ocean, the medium is water. For sound waves, the medium is air. They named this invisible medium ether, or luminiferous ether. It was invisible and undetectable, but some people thought it accounted for why light always went the same speed. And finally, that's where Einstein comes in. After reading a book about Maxwell's theory of electricity, Einstein didn't buy the ether theory. Also, by that time, there had been several failed attempts to measure the ether, the most famous being the Michelson-Morley experiment. By discounting the ether, Einstein was effectively pulling the pin out. Suddenly, Einstein saw a universe where everything was relative, and the only thing that mattered was your own frame of reference, and it was okay to marry your cousin. Well, everything wasn't relative. The speed of light was constant, and there's still restrictions on your marriage options. Einstein liked Galileo's theory of relativity, which basically was this. If a scientist was in a boat on calm water, going at a constant speed, and there were no portholes, there'd be no way for the scientist to know he was moving. He'd be able to carry out experiments such as rolling balls down inclines and swinging pendulums exactly like he would on land. Einstein's special theory of relativity was like that, except the boat is going at light speed. Yeah, Galileo didn't think of that. I think most people watching this probably know the basics of the theory, but I'll do a quick review. Then I'll get right back to the planet Vulcan. The special theory of relativity only concerns the boat going very fast in a straight line. Well, Einstein actually liked using trains and spaceships in his thought experiments, but I already drew the boat. You got your time dilation, you got your Lorentz contraction, and these things account for why you measure light at the same speed no matter how fast you're moving toward the light source. Now, Einstein's general theory of relativity adds acceleration to that boat. On the boat, acceleration acts like gravity. If the boat was accelerating through space at 32 feet per second squared, it would be like being in Earth's gravity. Like before, a scientist can do experiments such as rolling balls down inclines, and he wouldn't be able to tell he was moving, but this time, instead of gravity being provided by Earth, everything is being pressed against the deck due to the acceleration. Now, suppose someone shot a hole in the hull of this increasingly unlikely boat. From the time the light entered the hole and made its way to the other side of the hull, the boat would have moved up a little, so it would give the appearance that the light was not traveling in a straight line. To the scientist, it would seem to be curved by gravity. When Einstein added an explanation of gravity to the theory, that's when he started eyeing Vulcan with malicious intent. He had a hunch that Mercury's wonky orbit had something to do with a slight misunderstanding of the effect that the Sun's enormous gravitational field had on Mercury. His idea was that space and time are linked, and mass curves space-time. It curves it in a fourth direction, a direction nobody can point to. This curved space-time affects how mass moves. Mass tells space how to curve, and space tells mass how to move. He figured this bending of space and time should affect Mercury's orbit just enough to account for the disagreement between observation and Newtonian physics. In 1913, he applied the theory to Mercury's orbit, taking aim directly at Vulcan. Okay, that was a setback. He worked on the theory for years before he thought he had it right. Before he published the results, he plugged the changes into his old calculations. He was able to show that the general theory of relativity accounted for the small hitch in Mercury's orbit. That gave him the confidence he needed to publish the theory in 1915, and that was the end for Vulcan. Calculated out of existence, an ignominious ending as endings go. Vulcan now only exists as a fictional place in Star Trek. Oh wait, J.J. Abrams blew that one up. Now if you're thinking that maybe it seems that Einstein was making the numbers match the observation, you should know about the light bending experiment. Einstein predicted that gravity would bend light. He proposed an experiment. During a solar eclipse, you should be able to see the light of a star behind the sun bending due to the sun's gravity. He also calculated how much it would bend. The experiment was done in 1919 and confirmed the theory. Since then, there have been other confirmations. It's been almost 100 years since Einstein published his general theory of relativity. The universe was a different place back then. They knew that the Milky Way was probably a flat disk of stars and that we are on the edge, and evidence had been piling up that some of the little cloudy spots in the sky called nebulae were actually island universes, and the word galaxy took on a new meaning. In 1934, Fritz Zwicky saw that galaxies in the Coma cluster were behaving as if they had more mass than would be expected from their luminosity. In 1970, Vera Rubin measured the rotation of stars around galactic centers, and that too suggested more mass than expected. Also, remember how light was bent by the gravity of the sun? It's called gravitational lensing. Galaxies do that too, and scientists can figure out the galactic mass from that. So this suggests that there's matter that we can't see surrounding galaxies. Not only does it not emit light, it doesn't seem to obscure light coming from that galaxy. This is, of course, the stuff we now call dark matter. The theory that there's something called dark matter seems to be widely accepted, and it also fits with some other theories. Just like the perturbed orbit of Uranus suggested Neptune. Still, scientists are ever cautious. After all, dark matter could turn out to be like Vulcan, which seemed like the logical explanation for Mercury's orbit, but it wasn't. If dark matter doesn't exist, it could mean that scientists will have to rethink physics again. There are those that view this lack of certainty as a weakness of science. They have their own ideas about what makes the galaxies spin. But science is about finding answers, not having answers. It's not only okay for scientists to say they don't know something, they have to say it in order to get grant money. In science, an unexpected outcome is not an embarrassing outcome, it's a discovery. If science was so easily embarrassed, why would people publish the hard questions? People like Fritz Zwicky and Vera Rubin are honored by their achievement. Why was Leverrier comparing observations against calculations? That sounds like a boring and thankless job. Why invent more accurate methods of measuring the speed of light? These are all ways of testing and expanding our knowledge. Maybe the universe will never give up its secrets, or maybe it will, and I won't be able to understand them. Still, I appreciate all the dedicated people who figure these things out. People like Albert Einstein. So now we recognize a real man of genius.
Real man of genius.
This one's for you, Albert Einstein.
Albert Einstein.
As far as I know, you're the only person to destroy a planet with math.
Not like they did with Pluto.
You changed the foundation of physics, but all you got was the Nobel Prize for the photoelectric effect.
Like that thing in elevator doors.
Your biggest mistake was the cosmological constant, and now scientists think you were right in the first place.
I don't know what that means.
So take your place among the greats, Dr. Einstein.
Albert Einstein.
Quantum Darkness, YouTube USA.